Good morning, Bachu. This is the syllabus of our Unit 3. The first chapter is all about bending of beam that already we have covered. Right, here we have derived bending equation and derive an expression for bending stress, bending moment and geometrical features of the beam. Right, for uniform bending. Second chapter deals about the twisting of shaft, which is in particular case is also known as torsion. Right, now we will focus on this chapter. Right, and after that we will come to the third one. Before moving for the detailed analysis of this chapter, certain basic is required for this unit, and these basics are: first, we should know the difference between turning moment, bending moment and twisting moment, right? And second is difference between shaft, some basic concept, that is definition and difference between shaft, axle and spindle, right? So first we are going to answer the first question, that is difference between turning moment, bending moment and twisting moment, right? Now, what is turning moment? We know that moment is just the motion effect of force, right? Then what is turning moment? This moment tends to rotate a body about a fulcrum. Name refer. Here, moment effect of force is just about to turn the body about a fulcrum, right? Simply say moment effect is turning. When moment effect is simply turning, then this is known as turning moment. So, ideally, turning moment tends to rotate a body about a fulcrum. Example is when door hinged at a base, right? When we apply a push force, door move, rotate or turn about its hinge. Here I have taken an example. Here a scale suspended on a wall through a nail. Nail is considered here as a fulcrum, right? And this is our scale. When we apply a horizontal force P at this point of this scale, at the distance t from the top position or nail position of nail, then what will this force P do? It will try to turn this scale about this nail. Suppose this nail is fixed, right? Here this scale is fixed at this nail, and which is considered at a moment point of fulcrum. And if we apply a horizontal force P at a distance t from this nail, then this force will try to rotate, or this will try to turn this fulcrum about this point in anti-clockwise direction. So sometimes it's denoted by M, and sometimes we denote turning moment by T, then T equal to P into D. Here this scale is free to turn, right? This free to turn about this fulcrum. The sole effect of moment is turning, right? Now come to bending moment. What is bending moment? This moment tends to bend a body about when it's fixed in, right? Here, body get bends about a fixed end. For example, we have covered that suppose a column, beam is fixed at one end and the other end is free to take a load. Then what will happen through this load? This load will move this portion, right, up to a certain distance. Clear? Say this force is P is placed at a distance T. What we see that this force is bent. Initially it is straight, now it is moved into a curvature shape. So we will say that it is bent, right? It is bent. It is not in a particular position. In case of turning, there is no change in texture of the body, right? In case of, but whole body is turning, whole body is turning about a fulcrum, right? But here it is not happening. Do understand that body texture is changed due to this force P. Then we will say that if we have a 3 rupee pin, then like a body bent like this one, right? Due to the force, this curvature. Clear? I'm taking a pin. Here I have example. Suppose this is our simply supported beam. If we apply a load, then what will happen? There is bending. Clear? There is bending. There is change in the texture. There is change in the shape of the body. Change in the shape body. But in case of turning, there is no change, right? Whole body is turning. Whole body is moving about a point. Clear? But here, body is changed. Shape of the body is changed. Your body is moving. Your body bent about when it's fixed end. Here it is bent. Right? So this is bending moment. They have the same mathematically. They will be expressed by the same formula. There will be a force and perpendicular distance between the line of action of the force and the point about which they are moving. Clear? Now, what is twisting moment? This one is very important. Twisting moment, because there is a very slight difference between turning moment and twisting moment. Now we'll cover it. Right? Twisting moment, usually it happens in the shaft. This moment tends to twist a shaft about its one fixed end, right? Why we are considering shaft? Because twisting moment always happen in rotating member, right? Where rotating member, shaft always rotates about its axis. Clear? But when we measure twisting moment, then shaft neither bends nor rotates. In this case, there is no rotation, right? Because for twisting, here we see that suppose there is a fiber AB, right? AB, and due to the twisting, AB is moved to A dash. This AB is moved to A dash B. Finally, it is position of this fiber is AB, and due to the twisting, A is changed to A dash. If we consider the whole rotation, so if we are talking about the whole rotation, then AB through whole rotation, AB should come to this position and things like this way, right? AB will be here, but it's not, because one end is fixed and other end is free to rotate, right? When we are analyzing twisting moment, then twisting moment says that one end of the shaft should be fixed and other end of the shaft should free to rotate. In this case, twisting happens. So it is written in the definition that this moment tends to twist a shaft about its one fixed end, right? When we are talking about twisting moment, when one end of the shaft will be fixed. But when we are talking about turning moment or torque, there is no such a case required, because we know shaft uniformly rotates along its axis of rotation throughout its length, right? Here the torque value of the torque at this point and at this point will be the same throughout its rotation. Clear? But what is twisting moment? Twisting, when we are talking about twisting moment, then this moment tends to twist a shaft about its one fixed end. Clear? But during the analysis of the shaft, right, we generally assume that turning moment or torque and twisting moment, they are same. Clear? Now, this is the answer of first question, right? What is the difference between turning moment, bending moment and twisting moment? Now, we will answer the second question. Second question was the basic concept and definition of shaft and difference between shaft, axle and spindle, right? Now, come to the shaft. What is shaft? Shaft is a common and important rotating machine element, right? Because up to this standard, we first time introduced the concept of shaft, right? So it is a common and important rotating machine element. Why it is important one? Because this is the only mechanism till now which is widely used for what? For transmission of power, for the transmission of power from one gear or pulleys to another gear pulley mounted on the shaft, right? In general, shaft has a circular cross section and they are the length members, right? So what is the main purpose of shaft? Purpose of shaft is to, as a shaft is used to transmit power from one gear or pulleys to another gear pulleys mounted on the shaft, right? Now come to the difference between shaft, axle and spindle, because they have the similar forms. Sometimes they are also known as two similar forms of shaft, right? Now come to the axle. We have seen axle in our automobiles. The axle are basically non-rotating member. Axles are basically non-rotating member. If they are non-rotating member, that means they do not transmit torque, right? So axles are basically the non-rotating member and used for supporting rotating wheels. They use for the supporting purposes, right? But what are the spindle? Spindle are basically they are defined as a short shafts, right? Shaft in short dimensions are basically known as spindle, right? Design of these three things, shaft, axle and spindle, almost same, right? We go through a common design procedure for making shaft, axle and spindle. Generally, shaft is acted upon. The types of load acting on the shafts are bending moment, torsion and axial forces. Clear? Bending moment, torsion and axial forces. In further lecture, we will discuss in detail the combined bending and torsion effect on the shaft along with the axial forces. Right? During the analysis, bending force and axial force, they are combined into a resultant one, and another force is torsion. So always they are analyzed for two force. First, the resultant of bending moment and axial force, bending force and axial force, and second is the shear force generated by the shearing stress or turning moment acting on the shaft, right? Here, talking about the shaft, so first time we are studying it, so we should know what are the material for the shaft, right? The material for the shaft that we use are ferrous, non-ferrous and non-metals according to the application of them. We generally make ferrous, non-ferrous and non-metals, but in most of the applications we use ferrous shaft, right, made of cold drawn plain carbon steel, right? This one is highly used, right? And in plain carbon steel, this one is also used, hot rolled plain carbon steel and alloy steel. They are used for sophisticated engineering applications, right, where high strength, temperature resistant shafts are required, right, like a propeller engines, clear, of shipbuilding industries, aircraft industries, right, where therein we use alloy steel, right? Now, design consideration of shaft, why we are studying shaft, what we have to calculate, we have to estimate, like we have done in bending of beam, right? So there are two analysis, like the beam, strength and stiffness analysis of the shaft, because shaft is also a structural member, right? But it is a rotating one, so there is a strength and stiffness analysis of the shaft, and both we are going to cover in further our lecture. During strength analysis of shaft, we will estimate the shear stress developed due to the turning moment torque developed on the shaft, and during a stiffness analysis of the shaft we will estimate the angle of twist, maximum angle of twist that can happen due to the twisting moment of the shaft, right? So these two estimations are our objective, right? These two estimations are our objective, power objective of this chapter of this unit, right? Estimation of shear stress and estimation of angle of twist. And when we when we compare it with the torsional strength of the shaft, then finally there is an equation developed which is known as torsion equation. One portion of torsion equation is known as strength equation and another portion is known as stiffness equation. During this analysis we will develop a strength equation, and during this analysis we will develop a stiffness selection, and combination of these strength and stiffness equation is known as torsion equation, right? So this is the power objective of this unit. And for the lecture we will cover a strength analysis of shaft and stiffness analysis of shaft.